Hi there and welcome to Aid's Workshop. An interesting little job's come up where I've got to machine a hexagon on the end of a small brass component. I'll give you a quick close-up of that. So this is the component. It's got a 9.5 diameter, metric, by 14mm long, M6 right down through the middle, then a, clean up on half-inch bar is 12.7, 12.6 diameter, 2mm thick, and then a 10mm across the flats hexagon on the top, 5mm high to accept. See if I can do it without it falling over on camera. Not quite, bear with me. There we are. And it goes into a 10mm spanner nicely. Okay, so I'll show you how I went about making these in a productive way to make it as quick and easy as possible. Because as you can imagine, I had, I got to do these in batches of sort of 20, 30. And if you've got 30 of them and there's 6 flats, that's 6 30s, 180 machining operations to put those flats on. So you want something that's quick and effective to do it. So I'll show you how I went about it. I've got my half-inch bar up in a 3-jaw chuck, and I'm setting them as a blank to be approximately 28mm sticking out of the chuck, and that'll allow me room to part it off. And as usual, first job, face it off. Next step is to set my fixed stop. I'll give you a close-up of that until my DRO reads 14. Now I've set it up approximately, let me just give you a view, where are we, 13.45, okay. So what I can do is go down to my fixed stop, down here, and just with a little bit of adjustment, just bring it in a touch. And that gives me my fixed position when the carriage is right forward, bringing back to 14mm. Okay, so my next procedure, sorry I'm moving you around a bit here, is going to be machine that down to 9.5 diameter until I hit that stop at 14mm. So I'll get on with that. So I'm doing a final cut now to a dimension of 9.5mm, and I can basically, I'll just use the feed on this last one. I've been hand feeding it. Just taking the final point 2. As I approach the shoulder, knock the feed off, finish it to the shoulder. I'm just going to set my DRO to 0 and wind out. So that is 9.5 diameter, 14mm back to a shoulder machine. So that's step 1. So having machined the first one off, to make the next ones quicker with all my readings set, I bring my carriage, it's still on 0 when it's against my stop. If I come back 14.5mm, there we are, just bring the tool forward. Sorry for getting in your way here, but I can just loosen the chuck, bring the bar to touch the tool, tighten up the chuck. Now I can machine that front face to 14mm, just wind it back just a little touch. There we are, that's 14mm on the readout. So now that I've got all my settings on the readout set, I'll show you how quick it is. I'll face it off at 14 on the DRO, that's that. Come back out, set it at 0.2, that's 0.4 of a mil from its finished cut, hand feed across. Till I get to 0, wind in, till I get to 0 on the DRO, finishing cut to 9.9 diameter, and the feed this time just to give a better finish. Knock it off just before the shoulder, wind into the 0 again, wind out, and that's that done, ready for parting off. You can see how quick it is. So my finished size for the head is going to be 7mm, so I'm leaving 0.5mm on for facing afterwards. Part them off with 7.5mm. High-speed steel tool for this. I've broken the front two edges as well with a file off camera. And off she comes. Rinse and repeat 20 times. So I've turned it round in the chuck, pushed back hard against the jaws. I'm not worried about slight marks on the area I've turned because I'm going to be turning 0.4mm off that afterwards. So I'll bring my tool forward, touch on the flat part of the jaw, set my DRO to 0, come back out 7mm, lock my carriage off and face it off to 7mm. Okay, rinse and repeat 20 times. So a whole string of 20 out of these now, machined up to this stage. Probably 20 of them around a minute each, so about 20 minutes. 10 minutes machining the, you know, probably, yeah, a minute. Probably about 40 seconds to one end, part them off about another 20 seconds, something like that, and to face the other end, you know, in that area. So, yeah, I'm about 25 minutes in with filming, and I've got 20 of them after setting up. So where am I at? Okay, I've got the blank, and I now need to mill the series of 6 flats on the head. Milling cutter in the headstock, some means to move this up and down and to index it round 6 times. So ideal scenario, a hex block, something like a ER20 collet holder in a hex block in the milling slide, and I could rotate the hex block 6 times in the milling slide, run the cut across and set my depth on the milling slide. Yeah, that's one way of doing it. In fact, that'd probably be the best way. However, it would take a bit of time for setting up. And secondly, I haven't got a hex block. So, we need a hexagon on this fixed to it in some way. How am I going to fit a hexagon to this? Bit of inspiration, bit of magic perhaps. I could always screw a very short M6 bolt into the end of it. Magic. Why didn't I think of that? So, we've got a hexagon on the end. I need some means of holding this that can be adjusted up and down for the depth of cut with a lock so I can fix it into position in relation to that hexagon. Let's have a think on that one. Well, I think that'll do it. Piece of aluminium. It'll fit in my tool post, which is adjustable up and down, and the hexagon bolt is on the back. So I can locate it and put it to center height, lock it in position with a reference to that hexagon on the back. Let's show you that in place. So plan A went something like this. If I use a square off the bed of the compound slide, I can locate it in 6 orientations like that. Pick a flat, tighten the bolt, it's fixed. Loosen the bolt, turn it over, pick a flat, next one along, machine the next face, so on and so forth. That's a bit time consuming again. I've got a lot of these to do. What I could do with is something spring loaded on here with a flat face that will roll over the top of and find all its spots. So I simply loosen the screw, roll to the next flat, tighten up, carry on to the next cut in the same place. Perhaps something like this. Oh, now that's going to work. That's cool. Little brass rod, thread on the back, rebate in here with a very small spring, quite powerful spring. You know, it will, if I try and put that in, it'll bring its way back, as you can see. Powerful enough to keep that flat. So I mill across the top, loosen the screw, move on to the next, tighten up, carry on. I think that's going to be quick and simple. What cutter am I going to use for the job? I've got boxes of these things. Quarter shank 532 cutter. Nice and delicate for cutting these flats and more than long enough. And fitted up in the headstock in a collet. Oh dear. I haven't got a quarter collet. The smallest I got is an 8mm. Note to self, buy some quarter collets. Oh well, I'm going to have to hold it in the chuck. Yuck. Absolute yuck. Don't like that at all. That cutter in the chuck like that could move around, could do all sorts. But I have no choice, and you have to make do with what you got. But a quarter collet is on order, because this job does come up quite regularly. So, let's see how we're going to go and set up the depth. So I think I'll set how wide the face is first. So bring the carriage in until the job touches the end of the cutter. Set 0. Bring the workpiece out of the way, and I've set my fixed stop 5mm. So I can always come in, same depth of cut. So when I'm changing the part, I can wind away, wind back to that stop, and I know I'm always 5mm. There. So, a rough sketch, as you can see. I got my 12.7 diameter bar, which is the head, and I want it to measure 10mm across the flats of the hexagon. If I take the 10 from 12.7, leaves me 2.7. So that's how much has got to come off either side. So half each side, 2.7 over 2 is 1.35. So my measurement when I've machined the first one should be 11.35. I'll give it 0.05, or 0.05, I've written 0.5 there, 0.05, tooth hour side clearance, so it ends up 9.9 across the flats. So I need to machine the first flat until the measurement is 11.3 from the flat to the bottom of the part. So we'll get on, do a couple of setups, have a jiggle and a wriggle with it, and get that measurement right. So I crept up on it a bit, and now I can measure between the bottom and the top of that flat at 11.3. So I'll simply loosen off the little clamp screw, rotate it one flat. Shall I show you that again? I think my arm was in the way. Okay, loosen off the little clamp screw, rotate it one flat, make sure it's pushed back, tighten up the screw, take the next cut. I'm taking off 1.37mm in one cut here, and I set the depth of cut by gradually raising up the tool post on its stop, or the tool holder I should say, on its stop until I got to the desired figure. So a nice pass across here. I'll do this in real time. Back across. Loosen the screw. Round another flat. Tighten it up. And side number 3. Now how long would it have taken me to wind it all back out the way and turn a hex block, you know, with a collet in it, something like that, which I haven't got anyway, but to do that and set it up that way. I think for my purposes, without a milling machine, this is probably the quickest way I can do this job. There's another one. Oh. Next flat. Make sure it's back against the face. And off we go again. That cutter's running at 1300 RPM. It could probably go faster. It seems to be coping quite well there, so I'm going to leave well alone. Off with a screw. Rotate another flat. Make sure it's back. Tighten the screw. I think we're on the last one now. Loosen the screw. Wrong one. Lock. So as this is the first one, once I've finished this, I know I've got very square corners. Once I've finished this cut, I try a spanner on it, because it's the gauge. It has to fit the spanner. Just bring it back again this way. Right back out of the way. I've removed it from the jig. Removed. So I've removed it from the jig, and yep, no problem, and fits on socket wise as well. A little bit of detailing to do, and then we will have finished the job. So 20 more, rinse and repeat. So to set these back up again, I got a bit of M6 studding. It's actually quite a good fit on these in the chuck, and I'm screwing them on to form a sort of mandrel. It's quick and simple, and I can just, I've got a narrower 10mm spanner, I'll use that, but I can just nip them back to there. So my next step will be to finish the diameter to 9.5, which is where I wanted to be. So again, what I'll do is set my longitudinal stop. I'll touch that on the end, I know that's 0. Set my 0 on my DRO. Wind out, come in 14mm. Set my stop. If you can see my DRO from there, let's have a look. I've stuck it somewhere near where we can see it. There we are. So I just adjust a little nut on my stop till it hits 14. Lock the stop off. And they should be all exactly the same. So I'll just skim this down to 9.5. So I've taken a scratch, got a measure, and pretty much set everything up now so that I can do this in one hit. That's my 9.5. Radius on that corner, rake edge on there, and on with the next one. So everything's locked, my cross slide's locked, my compound's going to my carriage is coming to a stop. I'm only taking 0.2 aside. And the power feed there. Knock her off. To the corner. Back off. Nice radius on there. Break that edge. On with the next one. Quick as that. So for just some of the final little details, back on, tighten up. Again, I've set my carriage on my stop, put a nice chamfer on the top, on the hexagon, and a little brake edge on the flat, and that is the job done. I'll give you a couple of close-ups. So that's it, little flanged bolt, 9.5 diameter by 14, M6 right through, 1/2 inch flange, 6 flats to make the hexagon for a 10mm spanner, and on the top corners here you can see the little chamfer I put on, which rounds it into a circle on the top, and brake edges on the 2 corners of the flange. So that's pretty much it. I think probably total time to make one would be about 4 minutes. So if I had to make 20 of them, 420s, 80 minutes, you know, an hour and 20 minutes to make 20 of them. So not bad, as it's a job that comes up regular. Probably the quickest way to do it on my lathe, but I do need to get a quarter collet for that cutter. It would be much better with a quarter collet. I do hope you've enjoyed this little project. I did a miscount, I ended up with 22, but never mind, I got 2 for the next batch. Yeah, interesting little thing. It's just something when you haven't got the equipment to do something, when you're going to make something to suit to get the job away, and try and make it as efficient as possible. So yeah, something a little bit different. Indexing, I suppose you could call it. It's 6-point indexing or hexagon indexing when you've got nothing other than the hexagon on the end of a bolt to do the job with. I've been Adrian. Thank you for watching, and if you haven't already done so, hit the subscribe button, guys. Cheers now.